Alright, this is a 2-2 video where we're going to add, subtract, multiply complex numbers. This may be one of the easier things that we do, but let's go ahead and get started with the adding and subtracting part first, and then we'll dive into the multiplying second. So when it comes to adding and subtracting, when we add and subtract complex numbers, we want to simply, it's going to be more like combining like terms. So I'm going to say we're going to combine the real parts and then combine the imaginary parts. And let's do a few examples of that and see what it would look like. Alright, so if we had, let's say we have 3 plus 2i, and then let's say plus 4 minus 6i. Alright, so we're looking at two distinct complex numbers. We have 3 plus 2i and 4 minus 6i. So when I'm adding these together, what I'm looking to do is I want to combine my real parts. So I have a positive 3 and a positive 4, so that would give me a 7, right? And then a positive, then I look at my imaginary part. So I have a positive 2 and a negative 6. Well, 2 to the right, 6 to the left leaves me at negative 4 for the imaginary parts. And that is that's the extent of that problem. Now, ones that are going to look a little silly, a little goofy, and I want to see what these might turn into. So, what if happens if I have I plus 2i? Well, think about this like x plus 2x. If I had x plus 2x, I know this is 1x plus 2x's, and I get a grand total of 3x's, right? Well, the same thing goes here. I plus 2i would simply leave me with 3i. Right? Let's try one more. Let's see. However else might we see this? You may see this as like 4 plus I minus 2 plus 3i. Alright, now if you see this, alright, so here 4 plus I is the first complex number, minus 2 plus 3i would be the second complex number. If we see it in this form, there's that negative 1 sitting right here, right? So you really have that negative 1, and I want to distribute him through. So I'm going to drop my parentheses and distribute the negative 1 to the second complex number. So I'll end up with 4 plus I, and then negative 1 times 2 is negative 2. Negative 1 times 3i is negative 3i. And now I can simply combine the real parts and then combine the imaginary parts. And here we'd have a 4 and a negative 2, and that's 2. A positive I and a negative 3i is a negative 2i. Now take a look. Here's something that's really interesting that's happening here. Is that we end up, every time we add or subtract two complex numbers, the solution, or the simplification, is yet again a complex number. And that to me is pretty fascinating. Let's see what happens whenever it comes to multiplication. So, when I multiply, so multiplying complex numbers, this is going to be very similar to multiplying polynomials, but let's just see how this process works. The steps I would probably suggest is there's probably going to be some sort of distribution. And then we need to combine real parts. And then we want to combine imaginary parts. And you need to really pay attention here. Just note or recall that I squared, right? I squared is negative 1. I squared, again, it's negative 1. All right, so let's try a couple of examples here. What happens if I have 3i times 1 minus 2i, right? So here I have a complex number of 3i, and I'm going to multiply it with a complex number 1 minus 2i. Right, so here we're going to distribute first. So I'm going to distribute 3i to the 1. So 3i times 1 is simply 3i. And then 3i times a negative 2i. Well, 3 times negative 2 is negative 6. I times I is I squared. Now, there's a reason why I told you this up here, right? I squared equals negative 1. It's really important to note. I need to replace him with a negative 1. So then I get 3i minus 6 times negative 1. And a negative 6 times a negative 1 is a positive 6, right? So then I'm left with 3i plus 6. Well, I want to write this in the form of a complex number. And remember that complex numbers are always in the form of a plus bi. So I want to rewrite this where my numbers go first and my real parts first and my imaginary parts second. So my final answer on this would be 6 plus 3i. Now it seems like a lot of steps, but just the reason why I want to take my time with these is to make sure that I know what I'm doing on each step, and I just want to take one tiny bit at a time. If you try and do multiple steps, when it comes to I squared especially, if you try and do 2 or 3 steps at once, that's where most people, most students have the biggest issues, is when they try and take a bigger bite than they really should. All right, don't try and do 2 to 3 steps at once. Take one step at a time. Really take your time with these. All right, let's try another one. Let's try 2 minus 4i, and let's multiply that with 5 plus 7i. All right, 2 minus 4i times 5 plus 7i. Well, this is a whole lot. This is going to feel like FOIL, right? I'm going to distribute the 2 to the 5 and the 7i, and then I'm going to distribute the negative 4i to 5 and 7i. So starting with the 2 times 5 gives me 10. And then 2 times a positive 7i is a positive 14i. Then I want to distribute the negative 4i. So sometimes it's helpful to circle the negative 4i. Hey, it's a negative. So negative 4i times 5. Well, negative 4 times 5 is negative 20. I times 1 is I. And then negative 4i times a positive 7i. Well, negative 4 times a positive 7, that's a negative 28. I times I is I squared. Well, now I want to combine my real parts and combine my imaginary parts. Well, there's only one of the real parts at this step. So there's 2 things that we're going to do on this step. All right, so the 2 things that we're going to do. We're going to combine like terms. So I'm just going to write it like this. We're going to combine like terms, right? CLT, combine like terms. And then I need to remember, I squared equals negative 1. Right, so here, 10, and then now a negative 14i minus 20i is a negative 34i. And then I'm going to switch this I squared to a negative 1. So a negative 28 times negative 1. Well, negative 28 times negative 1 is a positive 28. So I'm just going to make this step plus 28. Well, 28 plus 10 is a positive 38. And then 38 minus 34i would be my final answer. Now take a look. This is really interesting. I think this is absolutely fascinating. We multiplied two complex numbers. We simplified and we ended up with a complex number. Right here we multiplied 2 complex numbers. We simplified and we ended up with a complex number. That is a very fascinating thing, and it's extremely interesting. In the realm of mathematics, things are never really that pretty, except for when it comes to complex numbers. There are some really interesting patterns that you should try and observe as you do this homework.